In this problem set, we'll be working with dividing powers. Now remember, when we divide powers, the numerator and the denominator have to have the same base. And if they have the same base, that means we can subtract the exponents. So let's take a look at our first example. We have 3 to the power of 3 over 2 to the power of 3. The base in our numerator is 3, but the base in our denominator is 2. So because 3 and 2 aren't the same base, therefore we can't subtract the exponents. So we're left with our final answer of 3 to the power of 3 over 2 to the power of 3. Now we have 4 to the power of 3 over 4 to the power of 2. The numerator and the denominator have the same base of 4, so we can subtract the exponents. So we have 4 to the power of 3 minus 2 to give us 4 to the power of 1. Well, anything raised to the power of 1 is itself, so our final answer is 4. Now we have 11 to the power of 7 over 11 to the power of 1. They both have the same base of 11, so we can subtract the exponents of 7 minus 1 to give us 11 to the power of 6. So our final answer is 11 to the power of 6. Now we have 5 to the power of 8 over 5 to the power of 8. The top and bottom have the same base of 5, so we can subtract the exponents. So we have 5 to the power of 8 minus 8, which leaves us with 5 to the power of 0. 5 to the power of 0 can either be written as it is, or it can be written as 1, because anything raised to the power of 0 gives us 1. So either answer is fine. Now we have 165 to the power of 13 divided by 165 to the power of 4. They have the same base of 165, so now we can subtract the exponents. 165 to the power of 13 minus 4 gives us 165 to the power of 9. So 165 to the power of 9 is our final answer. Now moving to our bottom left, we have 6 to the power of 5 over 6 to the power of 9. They have the same base of 6, so now we can subtract our exponents. 6 to the power of 5 minus 9 leaves us with 6 to the power of negative 4. So our final answer is 6 to the negative 4. Next we have 4 to the power of 2 over 2 to the power of 3. The base in our top is 4, but the base in our bottom is 2. Because 4 and 2 aren't the same base, we can't subtract the exponents. So we're left with our final answer of 4 to the power of 2 over 2 to the power of 3, which is the same as the original. Moving on, we have 3 to the power of 3 divided by 3 to the power of 3. Both have the same base of 3, so now we'll just work on subtracting the exponents. So we have 3 to the power of 3 minus 3 to give us 3 to the power of 0. Again, you can write this out as 3 to the power of 0, or we know anything raised to the power of 0 gives us 1. So you can also write this as 1. Our next question is 9 over 9 to the power of 4. Now this 9 has no exponent up top, so we can automatically say the exponent is 1. The numerator and the denominator have the same base, so now we can just subtract the exponents. So we have 9 to the power of 1 minus 4. Well, 1 minus 4 is negative 3, so our exponent is negative 3, and our final answer is 9 to the power of negative 3. Now looking at our final example, we have 2 to the power of 3 divided by 2. Now this bottom 2 has no exponent, so we can assume that the exponent is 2. They both have the same base of 2, so now we'll just work on subtracting our exponents. We have 2 to the power of 3 minus 1. 3 minus 1 gives us 2, so we have 2 raised to the power of 2, and our final answer is 2 squared.